Hello class. Okay, this is problem number 4 on I think Econ Policy class summer 2009, and this is the one about consumer and producer surplus, and there's some algebra and there's a negative externality. So basically in this particular problem we have a market failure, and I'd like to show you how you can calculate that. The first thing you need to do is find the equilibrium price and quantity that would come from this demand and supply curve. So setting quantity demanded equal to quantity supplied, I have, let's see, if I add 2,000 to both sides, I have 2,400 on the left side, and on the right side I have 6p. So dividing through by 6, I get an equilibrium price of 400. And then the equilibrium quantity would be 4 times 400, working from the demand curve, minus 400. So I get an equilibrium quantity of 1,200. And just so I can make sure I didn't screw up, I'm going to do it, let's see, that was from the supply curve. Now I'm going to do it from the demand curve. I should get the same answer. So it's 2,000 minus 2 times 400, which was the equilibrium price, and again I get 1,200. So I'm good to go. Now the market failure comes in because in this particular problem, if you look at the original problem, it says that we have a negative externality, that is an uncovered social cost. So maybe this is an operation that's polluting the air or the water, or maybe it's just loud and there's noise pollution, but these are typical externalities, or something in the production process that's a cost that comes downstream or downwind, and it's not covered by the basic accounting of the firm. So they pay obviously their labor costs and their raw material costs and so forth, but they don't pay for the cost of whatever this discharge is. So this discharge is estimated to be 60. So we have a new supply curve over here, because if they did pay that social cost, so sometimes this supply curve is called the social one, and then the original one is called just the private cost. So when you include all the cost to get up to the social cost, it's $60 more. So this is 60. So can you see this looks exactly like the supply and demand of taxes? So we would establish a new equilibrium up here, and the market price should be a little bit higher, and we can calculate what that is, and market output should be a little bit lower, and we can calculate what that is. So in the language of economics we would say it like this: because of this uncovered social cost, the market is overproducing this product. It's making a little bit too much out here at 1,200, and the selling price is a little bit too low at 400. And if all the costs were covered by the operation, then the price would be slightly higher and output would be slightly lower. Now to calculate those numbers is a little bit difficult, and it's mostly difficult thanks to Alfred Marshall. Do you remember this guy Alfred Marshall, who wrote our supply and demand equations slightly backwards from how they would be done in a regular math class? So what we have to do is figure out what that supply equation should be once we add the $60. Now there is a little shortcut that you can memorize, and I think I can remember it from the last time I taught this class, but I think the shortcut is you take the externality, which is $60, you multiply it by the coefficient on P, so 60 times 4 would be 240, and you subtract that number, 240, from the constant term. So I think the social supply curve should be 4P minus 640. I got that again by 60 times 4 is 240. 240 subtracted from a minus 400 would be minus 640. Now if you want, in fact, if you want, you could sort of do it the long way. Let me see if I can find a piece of paper and we can do that together. Here, we could try it like this. So you could take the supply equation, QS equals 4p minus 400. And you could undo Alfred Marshall's kind of crazy way he did things by putting p on the left side. So I'm going to subtract 4p from both sides. Now I'm going to subtract QS from both sides to get it on the right side. Now I'm going to divide through by minus 4. Dividing through by minus 4, that minus 4p becomes p, that minus 400 becomes 100, and that minus QS becomes plus 1/4 QS. So this is the way it would be written in a math class. Alright? That's the way a math class would write it. And then of course we need to add, I'll change colors so you can see, you need to add that $60 because we want to raise up the supply curve by exactly 60. So now I have an equation that looks like this. P equals 1/4 QS plus 160. Now I got to put back Alfred Marshall's mistake, and the way I'm going to do that is I'm going to multiply through by 4. So I get 4p equals QS plus 4 times 160. 4 times 160 is 640. Hey, I'm doing good. And now let's see what's wrong. I need QS by itself, so I've got to subtract 640 from both sides, so I get QS equals 4p minus 640. And that's right, isn't it? 4p minus 640. Yeah, so I remembered the little shortcut. So you can undo Alfred Marshall's mistake, add the 60, and put Alfred Marshall's mistake back. Or you can remember this little rule. You take the externality, or if it's a unit tax, you just take that number, multiply it by the coefficient on p in the supply equation, and then subtract it from whatever the constant term. And be careful about your signs, because the constant term was minus 400, and then we subtracted 240. Alright, so once you do that, it's not too hard to figure out what the price should have been. So it would just be quantity demanded equal to quantity supplied, except now we're using the original demand curve in the new social supply curve. So let's see, I had 2,000. I'm going to add 640 to both sides. So I get this big old number, and then I'm going to divide through by 6p if I put all my p's on the right hand side. So this number up here should be 440. Okay, and then since I know that the tax was 60, this part actually is a little bit easier than it was in the last problem we worked. Or I know that the social cost was 60. This number over here, well, I don't even need that number, but if I did, it would be 440 minus 60. It would be 380. I almost hate to write it here because it might confuse somebody, but that's what that number would be. Okay, so what's happened here is that we have a negative externality of 60, and if we can somehow incorporate that negative externality into the firm's decision making, or all of the firm's decision making, it would move the equilibrium price to 440, a little bit higher, and a little bit less would be produced. Now let's look at these questions for a minute. The equilibrium price without regard to the externality was 400. The equilibrium quantity without regard to the externality was 1200. This market failure overproduces or underproduces the product. Well, it overproduces. See, it produces here, and it should be over there if all the costs were considered. So it overproduces. The equilibrium price, if the social cost could be internalized with a tax, the equilibrium price would be 440 instead of 400, slightly higher. Equilibrium quantity, if the social cost could be internalized with a tax, that's this number right here, which I haven't found yet. So that would be, working from the demand curve, it would be 440 times 2, and that whole mess subtracted from 2,000. I get 1120. So this number should be 1120. By the way, you can check your work if you want, because that should have also you should also get the same answer from the new supply curve. So let's see, if you take the 440, multiply it by 4, and then subtract 640 from it, you also get 1120, so that's correct. So the answer to the question, equilibrium quantity, if the social cost could be internalized with a tax, is 1120. Now I think I'm off the page for you. Yeah, there's a couple more questions. The next one was, assuming a tax is used to internalize the externality, what would the tax revenue collected be? Okay, that's exactly like we've done in other lessons. Here's the tax that we would put on. This is sometimes called a Pigouvian tax, named after A.C. Pigou, P-I-G-O-U, the Pigouvian tax. And Pigou was an economist in the early 1900s who recognized that you could, theoretically anyway, internalize these externalities by just imposing a tax equal to the amount of the damage downstream. So the question was, assuming the tax is used to internalize the externality, what would the tax revenue collected be? Well, it would be $60 times 1120. 60 times 1120 is 67,200. So this number, well, you can't see it. I'll just write it up here. It's 67,200 is the amount of the tax that would be collected. And then question 7 was, theoretically, who should receive that tax revenue? And the answer is, well, it should be the people who've borne the cost. So whoever those people are, whether they be people downwind or downstream or whatever the externality is, they should be the ones to receive that compensation. And then question number 8 was, unlike the regular tax problem, in this example, would there be a deadweight loss? And the answer is no, there would not. In fact, I haven't shown it, but the deadweight loss existed originally because the market was overproducing this product, and then by internalizing that externality, the deadweight loss is eliminated. Okay, so if you wanted to, in that particular problem, I didn't ask you to calculate consumer and producer surplus, but it could have been done simply by finding these numbers. Right? Finding these numbers here, it'd be possible to calculate the areas of those triangles. So I think this lesson has gone kind of long enough, and if you want me to actually calculate the area of those triangles for you, post me something on one of the discussion boards, and I'll try to produce that for you over the weekend. Okay, I hope you found this helpful.